Okay, still going to be solving some trig equations here, but now we're going to work, again, still kind of a basic style here, nothing too advanced. We're just going to work with, when we have something the same, we can factor it, right? If it's equal to 0, we can factor it. The last one we could just solve because there was one trig thing in there, there was just tangent. This one has sines and cosines kind of interdispersed. So here my thought would be, I could probably factor this thing out, separating those sines and cosines, and then solving each. And factoring is really nice when it's equal to 0. When the equation's equal to 0, that's when we might want to factor. If it's not equal to 0, factoring is not going to be overly effective. So on here, just like we would with anything else, we pick out what's the same in the different terms. In here, they both have a cosine. So we will factor out that cosine of x, right? We factor that out of there. And then we write down what's left. Here there's a 3, sine x plus 2, and all that's equal to 0, which is all fantastic. And what that allows us to do now is, since it's equal to 0, is we can split this into two separate equations, two separate ones. So we have one equation coming from this spot, one equation coming from here, and we solve it just like we would the tangent one. So on this side over here, we could write down cosine is equal to 0, perfectly fine. Do the cosine inverse, x equals cosine inverse of 0, which if we type that into our calculator, it will come out with exactly 90 degrees, which isn't too bad to figure out on there. So on that, we can type that one into our calculator. We get 90 degrees on that one. And then we go over to this one and say, okay, let's figure this guy out, right? So in this one, we'd have 3 sine of x plus 2 is equal to 0. And we go through solving that kind of algebraic. Subtract 2, divide by 3, take the sine inverse. So that's exactly what I'm going to do. I'm not going to go through that step by step. But again, we subtract 2, divide by 3, right? And then take the sine inverse. And if you want to do that step by step, that's maybe a little tough to see. There we go, sine inverse of that negative 2/3. And this is one I don't know off the top of my head, so I would have to grab my calculator and we go ahead and check that, right? So in here, I would go ahead and type in, I got my sine, sine inverse of negative 2/3, because that's what we have on there. And I'd find out, oh, hey, we get negative 41.8 degrees on there, or 81 degrees. So on here, negative 41.81 degrees, that's what we come out with. Now again, we do have to make some adjustments, and we have to adjust both equations so that they make sure we're in between 0 and 360 and that there's not extra ones. So first I'm going to go ahead and adjust the cosine one as well and just go on ahead and check on there. All right, so this one here is that 90-degree angle. So I would maybe draw my picture and say, okay, 90 degrees, that's way up top up here. There's a 90-degree angle, right? Where else might these things be mirrored, right? So we can mirror this all the way around. There's a mirror here at 180, there's a mirror here at 270 degrees, and there's a mirror back at 360, or, well, just 0 degrees, since we're saying, open parenthesis, we're not including 360, because that's the same as the 0 spot. So we know 90 degrees works, that's in between there, we kind of keep that one. And then we've got to check whether the rest of these also work. Two ways to check that. Way number one is just to use our super smart brains. Cosine keeps track of the x value. At this point, the x value is 0, so that's why it works. Over here, the x value is -1. That's not going to work. It's not going to be 180. This will give us a result of -1. We want the result to be 0. So that's not going to work. 270. The x value is 0. It hasn't moved left or right at 270. So that's going to be a possibility too. Even though your calculator will not tell you that answer, that's a possibility. And then if we check 0, actually the cosine of 0 or 360, either way, is 1 because it's forward 1. It's keeping track of the horizontal movement. That's what cosine does. So these would be our two options for cosine. Now, if you weren't sure on there, you could type each one into your calculator. You could Type in cosine of 0, you'll get an answer of 1. That's not correct. Type in cosine of 90, we know that one's going to work out, but that one our calculator told us. Cosine of 180 is going to be -1. Nope. Cosine of 270, type that in. Yes, you will get this result as well. So we have two options from there, 90 or 270. That's where this one comes from. Then we have to check here, where is the sign going to be negative 2/3 at, right? Where's it going to be that? So we check again. I'm going to draw a picture, just to make sure we get that. And then I just go around the circle and check. First, I'll draw the original spot, right, which is about -41 degrees, -41.81 degrees. That's where that one is. And then from there, we just kind of reflect where it is. I might do my, where a thing is going to be at, right? And I want to keep it so that the sign is -2/3. So I want to keep it in its negative spot. So this triangle, I would not reflect up here. Sign's positive. Sign's positive here. Don't go up. Sign's negative. That's what we're looking for. So I would reflect my triangle over there as well. And then I just figure out what angles move me to those triangles, right? So that we're in between 0 and 360. So I'd start at 0 and move around and go, whoa, 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 bam, I hit this side. So that's my first angle. That's 180 plus this much more, right? Because that's our reference angle, 41.8. So I just go to calculator, 180 plus 41.8. So this angle here would have to be a 221.81 degree angle, right? That's one of the possibilities there. Or possibly, I could go all the way around and get to this spot, right? Just start here, go, 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 and now we're over to here, right? So I've got this angle possibility as well, which some people are saying, well, that's just -41.81 degrees, which is correct. But -41.8 is not in between 0 and 360, so we have to adjust it. Simple way to do that, 360 all the way around, we're 41.8 degrees short, so we would take 360 and just subtract that. Now I'm going to use my calculator to double check because that's a lot of, switching over the 9s and the 10s. We just subtract that away, 318.19. Okay, so this spot's got to be 318.19 degrees. I take that there, right? So there's our other option. So in this case, there are 4 possible answers to this question. 2 of them coming from here, 90 or 270. Also, 221.81 degrees, 318.19 degrees, right? And if you're not sure, you're like, well, is that actually true? You can go right back up here and type the whole thing in and see if you get 0, right? So if I wasn't sure, I might type in 3 times sine 221.81 cosine 221.81 plus 2 cosine 221.81. So we just type that whole thing all the way in the calculator there. Again, it's a little tough to see, because it kind of wraps all the way to the end. And then we just hit enter and check our answer. Ah, man, some people might say, oh, that's not 0, but it's e to the -6. That means it's -9 we'd move that decimal place over 6 spots. That's pretty close to 0. It's not going to be exactly 0 because, again, we rounded this number a little bit to get that 0.81. It was technically lots and lots of digits, but that's pretty darn close to 0. So I would say that one checks out. And same thing will happen if you plug in that one, or if you plug in these, you'll actually get exactly 0 if you plug those ones in. And that's how you work that with factoring. Factor them out. Check all of your options. Okay, that's the part that people sometimes forget, is checking these extra options so that it's in between 0 and 360. Give that next question a try, and then we'll go over some advanced topics. There's a little more advanced ones where we're using the quadratic formula or possibly, moving stuff around.